Good morning. I am Devi Abhirami, Assistant Professor, Department of Mathematics. Today I am going to explain the lecture video in the subject Discrete Mathematics with Probability and Hypothesis Testing, and the topic is Test of Hypothesis, Small Sample Test. Problems and its solutions are discussed in this PPT. My first problem is a sample of 10 students has an average test score of 72 and the sample standard deviation is 8. Test whether the mean score is different from the hypothesis to population mean of 75. Compute the t-test. They have given the data as the sample size and the mean value, standard deviation value and the mean score for the population mean. From this value, we are going to calculate the t-test. T-test statistics is nothing but student t-test, population of student t-test. This can be calculated by using the formula x minus mu by sigma by root n. Whereas the given part is sample size n is equal to 10, sample mean x is equal to 72 and the population mean is denoted as mu naught, that is equal to 75, and the sample standard deviation s is equal to 8. So now I am going to substitute these value in my formula. I already told that the formula is x minus mu naught by s by root n. So I know all the values of this formula. So if I substitute it, I will get the answer as minus 3 by 8 by 3.162. If I divided it, I will get 2.53. Final divide minus 3 by 2.53 will give you the answer minus 1.19. So here the degrees of freedom is 9. So the t-test statistics value is minus 1.19. This is how we have to calculate the one sample t-test for the given following data. And my second problem is, a food delivery company claims that if the average delivery time in a metropolitan city is 30 minutes or less. To verify this claim, a quality control team randomly selected 16 orders and recorded the following deliveries: 32, 28, 35 and so on up to 30. Here the alpha value is 0.05. Perform one sample t-test to determine whether it is true mean delivery is significantly greater than 30 minutes or not. This problem can be solved by taking the hypothesis. There are two types of hypothesis. One is null hypothesis and another one is alternate hypothesis. Null hypothesis is a significant difference between the two mean values, whereas the alternate hypothesis reject the null hypothesis and there is no difference between the mean value. So we can perform one sample right-tailed t-set. I am formulating the hypothesis as null hypothesis h naught is equal to mu less than or is equal to 30 minutes. Alternate hypothesis can be taken as the opposite one. If it is less, and we can take the alternate hypothesis is greater. If the null hypothesis is greater, then the alternate hypothesis will be less. So mu greater than 30 minutes. Level of significance is 0.05 and the t value is 1.753. So they have given the data. For using the formula, I need the value of x bar, so that I am calculating the x bar by using a mean formula. Mean formula is nothing but the sum of the population divided by total number of population. Here the sum of population is 512 and the total number of population, that is the delivery time sample size is 16. So if I divide it, I will get 32. Therefore, the standard deviation can be calculated by using a formula x minus x bar the whole square. It is explained in this tabular column and the final standard deviation value is 212. Now I am going to apply this in my t formula. So t formula is x minus mu naught divided by s by root n. So for finding this value, the n value, number of observation is 16, x bar value is 32 and the population mean is 30. Standard deviation value is 3.76 and the alpha value is 0.05. If I divide it, I will get the answer as 2.13. Here the table value is 1.753. So my value is greater than. So we can accept the alternate hypothesis. But if we accept the alternate hypothesis, we have to reject the null hypothesis. So in the final conclusion that I have given that the mean delivery time is greater than 30 minutes. Therefore, the company claimed that the average delivery time is 30 minutes or less. It is not supported by the sample data. Okay, this is how we have to calculate the t-test by using a null hypothesis and alternate hypothesis values. Okay, for problem number 11, they have used Welch-Satterthwaite approximation. Welch-Satterthwaite approximation formula is df is equal to s1 square by n1 plus s2 square by n2 the whole square divided by s1 square by n1 s2 square by n2 the whole square divided by n1 minus 1 n2 minus 1. So this is how we have to calculate the hypothesis of an Welch-Satterthwaite theorem. So the final answer for using the Welch-Satterthwaite theorem is 8.89 divided by 0.2675. By dividing it, I will get the value as 33. So the approximate value is 33 for that problem. Thank you.